We've all been impressed with global forest diebacks, fires, bark beetles, these events that have transformed forests. What really is important for the future is the forests that replace these events. That depends on seed production by natural forests. We have almost no information on the biogeography of seed production. We don't know how much seed is being produced by which species, how it varies geographically, and how it responds to climate. We started the MASTIF network, Masting Inference and Forecasting, as a way to combine the raw data, the information we can get from two main sources. One source are long-term studies by ecologists where the same trees on the same plots can be tracked over decades. The other source is opportunistic observations that can come in through citizen science. The iNaturalist website we use as a place for citizen scientists to contribute observations. Jordan is going to take us out into the field with Rob and Haley to show us how these observations are obtained. We'll come back at the end and look at how we're going to use those in the vignette for this unit.
Haley and I are now going out into this longleaf forest with Jordan, who's back there, and we're going to try to figure out how she does the sampling for MASTIF.
So masting is the seed production of a species. My favorite part is definitely the field work. I love going to all these different places and getting in there and really getting to be out in the woods in those different places. I don't think that you get to experience that doing anything else. Even if you're just like going on vacation, right? Like you never have an excuse to like just go out into the middle of the woods and like hang out for the whole day. So it's pretty awesome. This year seems like a great year for hickories. They're really tucked in there. Great species to do crop counts on.
I can see why people would get addicted to coming out, taking walks, and counting seeds. You don't think in your head, you're like, oh, I'm gonna go count seeds, but it's really enjoyable.
So we look at seed production for a lot of different reasons. One of the main ones, and I think the most interesting to a lot of people, is its influence with wildlife, because it's often the main food source for much wildlife. And it's important to look at it year-round because you can have different masting seasons. So the seed production is just as important in the spring as it is in the fall. So our lab works alongside with NEON at 14 different site locations. We travel all across the US, going to these various sites, and when we go to them, we'll go into the plots and look at the trees that occur within those areas and take crop counts and tree measurements of those. But also while we're at these locations, we'll look at different species that occur within the site, but maybe not on our actual plot, so that we're able to cover more species in various habitats.
Now we're going to walk you through the steps that you will take to collect this data. First, you have to figure out what tree to select.
First thing that you do is identify the species, and that can often be the trickiest part, especially if you're not comfortable identifying species. But then each species has a different type of fruiting structure. Cones, you have berries, you have acorns, capsules, pods. So you have to know what structure to look for and what time of year to look for that structure. You don't want to ever count the flowers or the immature fruits because they often abort or won't produce as much as you had first seen throughout the whole year. So it's important to wait until it's prime fruiting season for that species to do the count. So you don't need many supplies to do crop counts. The big thing is your smartphone so that you can use the iNaturalist app. Binoculars make it a lot easier, and then a diameter tape. We'll go into an area, look at different species, and what we want is a variation of different size classes and different species. So typically, I try and get different size classes of the same species. So you can get one that's 2 centimeters in diameter all the way up to 30 centimeters in diameter. And why that's important is it tells us what age they actually become reproductive, which can vary a lot from species to species. So when you finally select your tree, you want to get a good vantage point of the crown. Once you find your vantage point, you look at the tree through your binoculars and locate as many of the fruiting components as possible. You would then give an estimate of the canopy that you're looking at based on the vantage point that you were standing. It can be anywhere from 0 to 100. DBH is diameter at breast height. It's at 1.34 meters. So on me, it comes up to my shoulders. For these ones that are off really branchy around where you would take diameter. You can go slightly above or slightly below this one because it does have so much branching at DBH and it's kind of bulbous. I would go above. Make sure that your DBH tape isn't twisted. It likes to. And so this is 15.7 centimeters. Crown stature is looking at the percentage of light that a tree is receiving, which can have a great impact on its seed production. So it's on a scale from 1 to 5. 1 being that it's a full open canopy that's often out in the middle of a field and its whole crown is being exposed to light 100% of the day. 2 is a dominant tree in the canopy where the majority of its canopy is exposed to light the majority of the day. 3 is a codominant tree where at least half of its canopy is exposed to light 100% of the day, or 100% of the canopy is exposed to light 50% of the day. It's often right alongside a dominant tree, or it's on the edge of a habitat. 4 is a mid-story tree that receives partial light. And then 5 is an understory tree that receives no direct sunlight. And they often are not producing. But it's important to capture those as well. iNaturalist is a citizen science-based platform where anybody can come in and log observations that they had seen, and you can also link them to various projects that researchers are using. Or even if you don't link it to a project, researchers can get on there and look at observations and use them within their research. So for our lab, our project is called MASTIF. So inside the iNaturalist app, you can go to More, and then that'll bring you up to projects. And then look up the search button at the top and type in MASTIF. And there it is. And then you can just press join. And now you're contributing in the Clark Lab. First thing you have to do is press the observe button, and it'll want you to take a picture first. These pictures are really important because we also want other people to come in and verify your identification so that it bumps it up to research grade. You need two identifiers to get it to a research grade. So I often try and get a picture of the whole tree, and then I'll zoom in. I'll walk closer and get a picture of its bark, any twigs or leaves that I can, or any fruiting components on the ground. So after you've done that, it's going to ask you what did you see. And we're looking at longleaf here. iNaturalist is cool that it is really good at identifying the species from the pictures. So if you don't have an idea, that it can help you at least narrow it down. It can get you to usually a genus, and then you can navigate the species. But often, a lot of times, it goes right to the species. And that's our first choice, is a longleaf. Yeah. It already takes your location. There are a few other questions on here. One that is important to us is whether it's captive cultivated, and that's just basically saying was it planted or was it naturally grown. So then you would hit projects and then turn on the MASTIF project, and that'll give you all of the parameters that we want to collect. I typically like to do the crop count first and then record it before I take any other data because I tend to forget it shortly after. So the crop year that we're looking at is 2020. The crop count is 11. And I saw about 80% of the canopy, so the crop fraction is 0.8. Because this longleaf is in an open setting, I would say that it receives light 100% of the day, so I would give it a 1 for canopy light. And then the last parameter that we want is diameter. So we would go take the DBH. This is 31.5 in diameter. And then that's all, and then you just press share. So it's super easy.
Too easy.
Too easy.
You're like, that's how I like to spend all my time.
That's what I do all day.
The vignette for this unit is going to show us how to take the observations that Jordan made in the field and apply them to questions about forest responses to climate change. Just as an example, you can see maps of where seeds are being produced and where recruitment is occurring. So this is important for understanding forests of the future, which depend on recruitment. The MASTIF data have allowed us to identify this hotspot of tree fecundity in the south central part of the continent. The analysis combined with FIA data, forest inventory data, has allowed us to look at where the recruitment success is occurring, which happens to be far to the north. The vignette for this unit will look at how to extract the data, how to analyze them, and address some of these kinds of questions. So we hope this video has helped you to understand the MASTIF network data, how to collect them, and how to use them.